Hello, I am Michael Kim, and this is my lab report 4 for Physics 2212, Circuits and Capacitors. To start, the purpose of this lab is to use energy and current conservation principles to predict the behavior of series and parallel circuits with resistors. This is achieved by measuring the values of potential difference and conventional current using tools such as ammeters and voltmeters, and also viewing the properties of capacitors and resistors. For fundamental principles, the conservation of energy and conservation of charge is present throughout the lab experiments, and the formula delta V capacitor plus delta V resistor is used to calculate a value present within the lab. The formula V is equal to IR is used to calculate current and resistance in various portions of the circuit lab, and the formula shown for RC circuits was used to calculate the RC value of the ideal circuit with our experimental values. For measurements of our series circuit experiment, our predicted value for current is 0.0204 amps, and the experimental value when tested on the simulation was 0.02 amps. When one of the ammeters was reversed, the ampere value changed to negative 0.02 rather than 0.02. And when the series was broken, as shown in the second image, the ammeter value read 0 amps, while the voltmeter read negative 3 volts. This was the case as the voltmeter can still operate on the open circuit while the ammeter cannot. When calculating the values of the change in voltage between the points shown in the third image, these are the results, and the sum of all the voltages adds up to 0 volts as it should. Using the values shown in the last portion, the graph of potential versus position around the circuit is seen to the right. As for why the voltmeter does not change the value on the ammeter, the voltmeter is supposed to have a resistance that is so large that no current is supposed to flow through it, and this is shown on the image to the right as there is no change in the ammeter value after being connected to the circuit. As for when an ammeter is put in parallel with a resistor, there's a new path that the current takes, and the ammeter value changes to 0.06 amps for both ammeters. Using values we found previously, we can calculate what our expected value for each resistor is, and these are shown to be relatively similar to the expected value that they are supposed to represent. For our RC circuit system, where there is a battery, a light bulb, and a capacitor, as time passes, the light bulb that is initially lit slowly dims. After this, when the battery is disconnected and the light bulb is connected to the capacitor directly, the light bulb is initially lit and also begins to dim until the capacitor is no longer charged. Because of this, and the fact that the light was dimming, it appears that the current is also decreasing, which makes sense as the voltage decreases within the capacitor as the voltage decreases in the discharge. To find the expected value of our RC circuit, we take the value of the capacitor times the resistance in the light bulb to find that the RC time should be about 6 seconds. And using experimental data where we take the natural log of the change in voltage over the change in initial versus time, we can find that the RC value of our experiment comes out to 5.988 seconds, which is very close to our expected value. For what would happen if the lab was simulated in real life using an actual ammeter instead of the ideal simulated ammeter, real ammeters have low yet present resistance, while the simulation ammeters do not. This resistance being present inherently lowers the current of the system. And for what happens if we used a real battery to charge the capacitor with no resistor in the circuit versus how that works in the ideal model. In the simulated model, the capacitor should be instantly charged due to the essentially zero resistance. However, a real-life model would have charge with a resistance value equivalent to that present within the wires, the battery, and the capacitor that are near but not equal to 0.